Later on in this video, I'll be sharing with you how I created this building with a time lapse. You'll see the entire process and development from the previous video to this one, but for now I'll be sharing the concept of how this was created from the start using a basic exercise. So let's get into that and let me show you how a simple concept can be extrapolated and turned into a script like this, where you can create a parametric design that you can change with your sliders. And that's what I do here. I post videos every week so you can learn the process. If you have any questions, let me know in the comments below, and you can also download this for free on my website, pettydavid.com. Thank you for being here, and let's jump right in. All right, to start, let's bring in a rectangle. So we'll go here to a rectangle component. We'll be using the X and Y size for the building. Let's go here to 40, and this will be building 1. The X and Y are going to be the same. Okay, now we want to get the corner points. So to do that, we'll bring in the component called discontinuity. This will give you the 4 points where the line segment turns the corner. And so now we have 4 points, but we also want to get the center point of these. So what we need to do is take this rectangle and go to explode. Now we can plug in the rectangle into the explode and the segments into a midpoint or curve middle. So now we have these points, the midpoints and the corner points. Now we can use a point component to kind of bring out the points as separate components. The only thing about this is this rectangle is created from the origin out here, and we want to move it to the center. So that way when we create a point, or we'll go here to construct point, we can use this as the midpoint rather than the corner point. So what we need to do is take this rectangle. So I'll double click here on the output to create a relay, move this over. Now we need to move this rectangle to the center. How do we do that? I use a move component and a vector move, or a vector XYZ. This way, we can plug in the X and Y, which are the same. Now, if we move this rectangle by this amount, it will actually move it to the corner. So what we need to do is move it halfway. So we'll do this. And divided by 2. So we'll go to / and 2, and this will give you a component where it's a division, but when you plug in A, it'll be divided by whatever number you plugged in. So we divided it by 2, so this vector divided by 2 in the negative direction, and when we plug that into the move, it'll actually move it to the center. So now whenever we change this, it will be from the center. And now the reason we created a relay is because now we can use this relay to plug in the rectangle, and now we can disable the preview on the original. So this becomes the module for our design. Here's the thing. I'd like to turn this into a cluster. What does a cluster mean? It means it simplifies the inputs and the outputs. So these are going to be the outputs, and I'll need to create a relay at the end. So it creates a clean cluster. So now I'll double click here. So if there's only one input, there's going to be another point input, which will be this. And now we can disable the preview on all of these steps here. Now we can go to middle click, cluster, And now this becomes our module. Well, let's actually undo this. We also need the rectangle. So we'll go here to a curve and T component. We'll place this. It'll be actually this one. We'll place this here, create a relay here. And the way that they're organized from top to bottom, that's how they'll be organized on your script or in your cluster. So let's go here, select these, middle click, cluster. Now let's move these and organize it. So now this small cluster becomes the rectangle component that we use for our module. So now that we have these corner points, we're going to copy this cluster, tap Alt. Now we'll be using the corner points as the input and changing the size. So if it's 45, we'll go to 20. And now we change the name to buildings 2, which means that this is going to be the size of these buildings. And we also have the corner points and the center points if we want to use those, because sometimes those are the locations for your windows or your doors. And lastly, we're going to do the corner points. Here's the thing. For the corner points on the outside, we actually take a different approach. So what we'll do is, let's just focus on developing between these two, and I'll show you the tricks that I use for that we take here at the end when I show you the time lapse. The concepts are going to be the exact same. It's just I want to display to you the different decisions you can make when creating a script. So with that being said, let's start with the core. We'll take this polyline and we will offset it. So we'll bring in an offset curve. We will plug in the curve into the curve input. It's offsetting to the outside, so I'll bring in a negative component and plug it into a, let's say 1.5. This is going to be the wall size or the wall depth. Okay, now we're going to create a surface between those two. Let's go here to boundary surfaces, and I'll plug in both the offset and the original curve. Plug the flatten input, so it comes in as one list. And here, now we have the base surface that we can extrude. So let's go here to extrude. In which direction? Up. And then we can give it a value for the wall height. So let's go to 12.5. All right. So now here we have the ability to change the size of the wall or the height. We have the ability to change the depth of the wall. So let's go here to 1. And now we're going to do the same thing with the forms out here. So we could either double click here and just use some of this information with this. So I'll move it, tap Alt. Now we're going to be plugging in this into the curve and these two. We can change the wall height. What I'm doing here is just organizing it so it's clear, all the inputs and outputs. And we can disable the preview on the steps before this. Okay, so now at this stage we have the ability to do a few things. We can either subtract from the corner buildings, so you have an L shape, or subtract from the core, so you have a whole corner building, and then you do have this cross shape at the end. So those are the different options that we have here. And depending on what you're trying to do, you would make whatever decision. What we're going to do on this one is keep the corner buildings as whole rooms and subtract it from the core. So that's the next step. All right, so we've taken care of most of the things. So what we need to do is take this outside rectangle, or you can also take the inside one, either one. Let's see how this works. We'll go to boundary surfaces to create a surface right at that rectangle. Now we will be using this and extrude it by the same amount as the wall height. So we can copy this, use the surface input. And this is not a step we're going to see, but we need to extrude this form so we can subtract from the original core walls. So let's go here to difference, solid difference. I'll be using the walls as the BREPS A and this solid as BREPS B. What happens is now this becomes, like I said, kind of a hidden step that you don't see, but it's necessary to remove the walls. So as you can see here, we have this corner building that intersects exactly with that, and it changes perfectly as we update our sliders. Now we're going to create an opening right in this corner for all of those. So there are different ways we can do this, but one way I like to do it is using a cylinder and a box. Let me show you. The center, we have the center point, which is the origin point where we brought in or we created the design. We're going to be creating a circle. We'll use this point as our plane input. Now we can use this circle and change the radius. So let's go here to 25, and we'll see how this changes the slider. And if we decrease this, it'll decrease the slider, and therefore we can take this circle and extrude it into a cylinder. So let's extrude this in the Z direction, and this is going to be the wall height or opening height. Let's actually go here to 12.5, and we'll do opening height. This will be opening size. And it could also be, let's say, if the full number, it could also be the number of the core, but either way, now we have this rectangle. We're going to lower this now. Let's go to 8. And I'll create a box around that. So when we do that, now we have, and like I said, this is just one way of doing it. There are different ways we could attack this. Now we have this box that intersects with the corner buildings. Now we can use a difference or a solid difference and subtract the box, so that goes in BREPS B, from the corner buildings. And then we have to hide both of these, and you'll see now that when we change the size of this opening, it changes the size of the opening for all of them. This next technique is going to be a bit strange because we only want to pick the outside of these for the windows. And I want to show you, actually we can just use the midpoints. I'm going to show you two different ways that we can do this. We're going to use the midpoint, and then I'll show you another technique where we could be more precise as to what we pick for our windows. One of the things that we made sure to do was to get the midpoints for all of those. So what we're going to do is do the exact same thing we did for the opening size for this, but do it for the windows. Now what I'll do is I'll take this, slide it down, then I'll tap Alt, and I'll create a copy so I can plug in the midpoint of the outer corner buildings. Now this is really large, the opening size. We need to make it 8.5 or so, maybe 6 feet. So this will be window size. Now when we preview the box, you'll see that it created a window or an opening at those building locations. Let's change this to 25. Let's subtract from that. So we'll take this and we'll subtract this. So solid difference. This will be subtracted, so that goes into B, and we can disable the preview. And now we plug this in. Now notice that this wire is different than this one. This means that it's coming in as a grafted set of information, and you want to flatten the input. So it comes in as one set. And now we can disable the preview and see that it creates an opening here, a window here, a window here. And we can change the size here. Here's the thing. This window size, it's 4 and 4, which means this is 8 feet. So if this is the window size, we technically have to divide by 2. So let's undo that. Divide by 2 and then override it. So now if I go to 8 feet, now that's true 8 feet because it's 4 and 4. What I'll do in this part is just go to this box and go here to enable, to disable the difference. Now we'll go bring these back because I want to show you. Technically, you could just delete this one and delete this one. What I want to show you is how to just get the outer points to be where we create the windows. So let's do that. Let's create an offset. And you'll see that what we need to offset is the core rectangle. So we'll go to the core rectangle, either from the relay or from here. How much do we offset by? By the building size, because we have this building size. But the building size needs to be divided by 2. So I'll create a relay here and show you that if you divide by 2, it will actually be at that exact outer location. Now we need to extract where these intersect with this. What I'd like to do is create a boundary surface right at those rectangles, and where they intersect, we'll extract a line segment. So we'll go here to under the parameters tab, or under the tabs here, we'll go to intersect, physical, brep with curve. Make sure that you plug in this surface as your brep, and the curve is going to be the offset. Now, notice that you only get the intersection between that and those. So what happens is you only extract those curves, which means that if I go here to explode, and I go to middle, you'll see that we extract 1, 2, 3, 4, 5, 6, 7, 8. If I go hover here, it says 8 points. Now we can use those. We can copy this over and create the openings at those locations. And then we can use that as the option of where we create the windows. Now I'll use the difference for solid difference as BREPS A and the box as BREPS B. As I said before, when it comes to the nested dash line, which is different than this one, we need to flatten either the input or flatten the output there. So we'll go to flatten. Now let's disable the preview on all of this stuff. Okay, as you can see, it gives you a different result, and the fact that it doesn't create a window here, and that could be useful because sometimes you want at least a wall to be free so you can place countertops or whatever at that location. So hopefully with this exercise, you're able to see how cool parametric design is. And if you have any questions, check out my website, cappettidavid.com. There you can find this script, video tutorials, and much more. Thank you very much for being here, and I hope to see you on the next one.